Bismillahirrahmanirrahim. For today, we are going to speak about the derivatives of the logarithmic functions. Giving the rules for the logarithmic function, then we are looking for some different examples to explain the idea. The derivative for the logarithmic function is equal to with base b. This is equal to 1 over x multiplied by then the base b provided that x greater than 0. This is the domain of the logarithmic function. X must be greater than 0. So this is the first rule. The derivative of logarithmic function of x with base b is equal to 1 over x multiplied by ln of b. Number 2, we have special case. Derivative of ln of x. Ln, it is logarithmic with base e is equal to log x with base e, where e is a constant equal to approximately 2.71. Because this is the natural logarithm. Natural logarithm. We have common with base 10 and we have natural which is with base e. Now the derivative of ln of x will be the same rule, since we have ln of b in the first one. In this rule it is 1 over x ln e. But ln of e is equal to 1. So it is only 1 over x. This is equal to 1. By the properties of the logarithm, ln of e is equal to 1. In general, we're going to use it for the chain rule, d by dx of ln or log of the function. Let me take the general one. Log base e b of f of x is equal to, the function is down with ln b and the derivative of the function will be up. This is the by the chain rule. It is f prime divided by f of x ln of b. This is the general rule for the derivative of logarithmic function. We are going to apply this one in the coming examples. But before doing that, let's take some properties, or I will keep this later on. Example number 1. Find the derivative. The following. Number 1. Y equal to ln x squared. I need to find the derivative of this function. Y equal to ln x squared. The derivative y prime is equal to, the function is down x squared. The derivative of this function is 2x. So it is 2x divided by x squared. This is the derivative. If we need to simplify it more, I will say it is 2 over x. By the coordinate of x with x to the power 2, it will be 2 over x. But the main idea is that the derivative is equal to f prime divided by f ln of the base b. And in this example, the base is equal to e. So no need to write a ln of e. Number 2. Say y equal to log with base 3 of 3x squared minus 1. Let's find the derivative of this function. Y equal to log with base 3 of 3x squared minus 1. The derivative y prime equal to, the function is down, 3x squared minus 1 multiplied by ln of the base. Base is equal to 3. So it is ln of 3. Now the derivative of this function is 6x. So that's it. This is the derivative of the given function. Y prime equal to 6x divided by 3x squared minus 1 multiplied by ln of 3. One more. Number 3. Y equal to, it is log of sine x, log of sine x. And we need to find the derivative of this function. The derivative is y prime equal to the function sine down multiplied by ln of. Since we don't have any base, it means base 10. So this is ln of 10. If the base is not mentioned in the function, it means that the base is equal to 10. Log with base 10. And the derivative of sine is equal to cosine x. So it is y prime equal to cosine x divided by sine x multiplied by ln of 10. We can simplify it more to say 1 over ln of 10 because the cosine over sine is equal to cotangent. So the derivative is 1 over ln of 10 multiplied by cotangent of x. Number 4. Y equal to ln of square root of x squared minus 1. Let's find the derivative of this function. Now the derivative is y equal to, or y prime is equal to, the function is down, which is square root of x squared minus 1. And since it is ln, no need to write ln of a down. So the function is 1 over square root of x squared minus 1. But this function contains more than one part. I have square root, I have x squared minus 1. So I need to apply the chain rule for this function. Chain rule. I have square root and I have x squared minus 1. The square root will give me 1 over 2 square root, and x squared will give me 2x. If we differentiate, square root will be 1 over 2 square root, and x squared minus 1 will give me 2x. So this will be multiplied by 1 over 2 square root multiplied by 2x. Now what is inside the square root? It is the function itself, x squared minus 1. So 2 will cancel with 2. Square root with square root will be cancelled out because I have squared. It will be y prime equal to x divided by square root with, or multiplied by square root will give me x squared minus 1. So the derivative is y prime equal to x divided by x squared minus 1. Can we do it in a different way later on? Yes, we will do it using the logarithmic properties. This is power 1/2, we can take it outside. We will do it later on in a different way. Number 5. let's have that y equal to sine square of ln x. Y equal to sine square of ln of x. Sine square of the ln x is the angle of the trigonometric function. This is not multiplication. Some students say that this is the product rule. No, it is not the product rule. Every trigonometric function must have an angle, and the angle in this case it is ln of x. So I need to apply the chain rule for this function to find the derivative. I have three functions. I have sine, and before sine we have square, the power. We have the power, then we have sine, inside sine we have ln of x. These are the three functions, which means that I will have three derivatives. The first one will give me 2 multiplied by bracket. Sine will give me cosine of the angle, and ln of x is 1 over x. So the derivative of this function will be the product of the three derivatives here. So y prime is equal to, start with the power. It is 2 multiplied by sine of ln of x. This is the first one. This is the power. 2 multiplied by sine. So we differentiate the power first. 2 sine to power 1 ln of x multiplied by. Now differentiate sine. Sine will give me cosine of ln of x multiplied by. Now derivative of the ln of x, that will be 1 over x. So the derivative of this function is 2 sine ln of x, or sine of ln of x multiplied by cosine ln of x multiplied by 1 over x. So this is the derivative. Let's take one more. Number 6. Let's have that y equal to ln of x. See how many functions we have here. We have 3 ln functions, 3 logarithmic functions, which means that I must have 3 derivatives. By the chain rule, we must have 3 derivatives. So the derivative for this one, y prime equal to, the first one will give me 1 over the function. Now the function for the first ln, if we just remove that one, the remaining will be the function. It is ln of x. This is the derivative of the first function by the chain rule. Now we differentiate the second one. Again, it is ln. So if we differentiate this one, the derivative is 1 over ln of x. Because my function in the second logarithmic function is ln of x. So we are done from the second derivative. Third one, I have ln. The derivative of ln is 1 over x. So the derivative of this function, y prime equal to 1 over ln of x multiplied by 1 over ln of x multiplied by 1 over x. Take one more. Number 7. Let's have this one, which is y equal to x squared multiplied by log of base 2 of 3 minus 2x. Since we have multiplication of 2 functions, I have x squared multiplied, so we have to apply the product rule. Product rule is f prime g plus g prime f. This is the product rule, f prime g plus g prime f. So y prime in this case equal to f prime, it is x squared. This is the first function. The derivative of x squared is 2x multiplied by log. The second function will be as it is, no change, plus. Now let's differentiate the second function. It is log of 3 minus 2x with base 2. So the derivative for this one will be 1 over, or the function down, which is 3 minus 2x, multiplied by ln of the base. The base is 2, so this will be base of 2 down. Now the derivative of the function, which is 3 minus 2x, is minus 2. So this is the derivative of the second function. And don't forget, product rule says that we have to multiply it by the first function, x squared. So don't forget that we have to multiply by the first function. It is f prime g plus g prime f. So this is equal to, we can rewrite it again, y prime equal to x, log of 2, 3 minus 2x minus 2x squared divided by 3 minus 2x multiplied by ln of 2. So this is the derivative of the given function. One more, number 8. Y equal to x divided by 1 plus ln x. X divided by 1 plus ln of x. This is apply the quotient rule. That is f prime g minus g prime f divided by g squared. So the derivative now for this one, by applying the quotient rule, y prime equal to, numerator is 1 plus ln, the denominator, ln x squared. Now differentiate the numerator, x will give me 1. The derivative of x is equal to 1 multiplied by the denominator, which is 1 plus ln x, minus. Now the derivative of the denominator, derivative of 1 is equal to 0. Derivative of ln of x is 1 over x multiplied by the numerator, by x. So this is equal to 1 plus ln x minus 1, because this x will cancel this one, over 1 plus ln x squared, or it is just ln x divided by 1 plus ln x all to power 2. So this is the derivative of this question. Y prime equal to ln of x divided by 1 plus ln x all to power 2. Number 9. Y equal to ln sine x minus, let's say, tangent. Now the derivative for this one, y prime is equal to, the function is down, sine x in the denominator minus tangent. Now the derivative of this function, derivative of sine, is equal to sine x minus derivative of the tangent, which is secant square. So this is the first part of this topic, that derivatives of logarithmic functions. Still, we have more examples and more ideas about this topic, where we need to use some properties of the logarithm, and that will be given in the coming part.